Welcome to our video on part 2 of our parabolas, day 2. And in this video, we're going to be looking at the applications. So let's go ahead and begin with our first example. We have the number of bacteria in a refrigerated food is given by this function. N is equal to 20t squared minus 20t plus 120. But it only is valid for temperatures greater than or equal to -2 and less than or equal to 14. So again, that would relate to our domain of the function. T is defined as the temperature of the food in Celsius. So what you want to know from something like this is, again, what's the X and what's the Y, or what's the domain and what's the range. So in this function, we're putting in temperature and we're getting out the number of bacteria. And again, it's important when you look at functions to think about the domain and the range. In other words, what are you putting into the function and what are you getting out? So what we want to know in this part A is how many bacteria are present at 6 degrees. Well, 6 degrees is a temperature, and so that means that we're going to be able to just take the function and replace all of the T values with the 6 degrees Celsius. And then we can evaluate for the number of bacteria. So again, what I'm doing is just putting it in a different color so we can see that we are replacing all of those T values with 6 degrees. And because 6 degrees is within the range given, there's no problem there. So when we evaluate, we're going to get N is equal to, so these are going to cancel right here, and then we're going to end up with the number of bacteria is equal to 720. So in part B, what we're looking at then is at what temperature where the number of bacteria will be minimal. That word minimal is important because that is telling us that we're thinking about the vertex. So when you see the words minimum or minimal versus maximum, then you should be thinking about the vertex. So if we want to know at what temperature the number of bacteria will be minimal, that is going to be, again, the X coordinate or the T coordinate of the vertex. So if you recall, if we have an equation in standard form, which is what we have here, we know that the vertex, the X coordinate, is going to be the opposite of B over 2A, or negative B over 2A. The Y value would be what we get when we plug that X coordinate in. So that means that we can go ahead and, given our different variables here, we can go ahead and find the temperature by saying that it's going to be equal to the opposite of B over 2A, because again, that's the X of the center, or the X of the vertex, excuse me. So the B term is -20. So that means that we're going to use the opposite of that, which is +20, over 2 times the A term, and the A term is also 20. So again, if we go back up here just to make sure we're clear, this is our A term, this is our B term, and our C term would be 120. So once we plug in those values for the opposite of B over 2A, we're going to get 1/2. That means at 0.5 degrees Celsius, the bacteria will be minimal. So now in the next part, what we're looking at is, it says, what is the minimum number of bacteria present? So again, we want to look for these clues. The number is the y of the vertex, or what we get out when we put in a temperature of 1/2. So again, what we were going to do here is know that we want the n of the vertex. So all we need to do is plug in 1/2 into the function that was given. So everywhere I see the t value, I'm going to put in a 0.5 or 1/2. And then I'm going to evaluate. So the number, let's see, is going to be, when we do this, we get 5 minus 10 plus 120, and that's going to give me 115. So there will be 115 bacteria at the minimum level. All right. So that is our first example. Now in our second example, what we're going to do is we're going to look at a profit model, which is very common for quadratic functions. So this model is telling us that the profit P can be modeled by this function. P of x is equal to negative 0.25x squared plus 132x minus 6,399. So x is the number of units made and sold. So we're putting in units and we're getting out profit. Again, important to think about what our x and our y is. So in this case, using the function notation here, I want to remember that this is units, and what I'm getting out is the profit. So it says, how many units must the manufacturer make or sell to break even? Well, breaking even means we're not making any profit. We're just covering our cost. So that means that the profit would equal 0. So again, important to kind of profit equals 0 when we're at the break-even point. So what we're going to do is we're going to replace the P of x here, or the y value, with 0. Let's get that decimal in there here. And then we can solve for the value of x. And we can do that a lot of different ways. We may try to factor it, but with something like this, I'm just going to probably put this into the quadratic formula. And I've got my a term of negative 0.25. I've got a b of 132. And I've got a c of negative 6,399. So when I put that into the quadratic formula, the opposite of b is negative 32 plus or minus the square root of 132 squared minus 4 times the a, which is negative 0.25, and then the b, which is negative 6,399. All over 2 times the a, which is negative 0.25. All right, so when I evaluate that, I'm going to get negative 132. I'm going to put this all into a calculator, and I'm going to get the square root of 11,025. And then here, this is going to be negative 0.5. So what happens is I get negative 132 plus or minus the square root there is going to give me actually 2 positive answers. So I'm going to end up with x equals 54. Let me just go ahead and put this into the calculator, and so the square root of 11,025 is 105. So this will make it easier for you to see where I'm getting these numbers. Our two values come out to integers. X equals 54 or X equals 474. So in other words, at those prices, or at those number of units rather, then the company is breaking even, meaning they're not making any money. How many units then must the manufacturer make or sell to achieve maximum profit? Well, maximum profit, remember, we want to think, if we see a word like maximum or minimum, we want to think vertex. So we want to go back to the idea that if we're getting the number of units, that is our x-coordinate of the vertex. Well, how do we find the x-coordinate of the vertex? We use the opposite of b over 2a. So here, again, we can use the a, b, and c that identified in the part A, and we can say, well, the opposite of 132 is negative 132, and over 2 times the a, which is negative 0.25, that's going to get me 264 units. Well, that means that at 264 units is the number to maximize profit. Now, what we're going to do is we want to then take that number and actually calculate the maximum possible profit. So remember, in our model, we're putting in units and getting out profit. So we're going to take the 264 and put that into our model. So again, I'm just going to rewrite the function, but everywhere that I see an x, I'm going to put the 264. So I'm substituting, and then I'm going to evaluate, and that's going to tell me my maximum profit. So, and again, the notation might be a little clearer over here if I actually make this P of 264, right? So we can see that that is what we are replacing the X with. All right, so when we evaluate that, our profit, if we plug this into a calculator, so when we produce or make 264 units, we have a profit of $11,025. So the maximum profit is $11,025. All right, so I want to tie part A, B, and C together by showing you what this would all look like on a graph. So let's go ahead and take, again, I went ahead and made a graph so that we could put all of this in a visual form. So if you remember in part A, what we did was we found the break-even numbers. And the break-even numbers were 54 units, and 474. So there were two, and again, remember, break even is when we're not making any profit. The profit is our y-axis, and our x-axis is the number of units, because remember, we're putting in units and getting out profit. So the break even is here at 54 and then at 474. Well, our maximum or minimum, but in this case, because it's a negative a term, it's going to be a maximum. Because of the symmetry, we'll be halfway between those points. So if we average 54 and 47, we're going to get 264, which is exactly what we got when we did the negative b over 2a. So let's go ahead and make a axis of symmetry here. And at 264, I'm just going to kind of draw a vertical line here. And our maximum would be at 11,025, so a little bit more than 11,000. And if I connect and make my parabola, then this is a visual representation of what we did. And you can see that the maximum is at 264 units, and the profit there is $11,025. That concludes this video